Hey guys, my name's Garen. I'm a former CNC machine shop owner, and I just built Machinable, which is an app that addresses a pain point in the machining trades. So, in simple terms, it answers the question for a machinist, it answers the question, what size raw material do I need to use for this job? And the sequence of events is the operator, the machinist, uploads a PDF part print to the Machinable app. The app reads the part print, extracts information from it, and then returns to him the bounding dimensions, but more importantly, the raw stock size that he needs to make the part. And it delivers that to him in a common stock size that's likely to be carried by his metal supplier. So I'm just going to show you how it works right here. So here I'm going to click choose PDF, and we are going to upload this VBlock. Now, part of the reason I came up with this was because I saw this as a frustration point for the guys in my shop, but I didn't want to just rely on that, so I scraped the machining subreddits from Reddit and also the Practical Machinist forums. And this is a very common complaint. It's not that guys cannot do this calculation on their own. You know, they get a part print, they read it, but it just requires time, manual math, and so it's just a bigger pain point than I would have expected had I not gathered that data. But here we go. So now this is kicked back. I think what I'll start out with here is it tells us our bounding dimensions. That's the hardest thing to do here, and we get that because I'm using GPT 5.6 Sol and 5.6 Terra to do separate vision reviews of the print, and they're both collecting the same information but independently, and then they're cross-checking them against each other. I find that this is the hardest thing to achieve with part prints because even the frontier vision models have a very difficult time with part prints, and the reason for that is the extension lines and dimension lines here. Those things really confuse the vision model, and it seems to be a function of tracing those lines back to the dimension. All right, so it's given us the proper bounding dimensions, and you can see that over here by looking. You got 2-inch length right here, and then the width dimension you can see over here is 1.06, and then the thickness dimension 1.175, which is right here. Okay, so then what it does is it basically runs a deterministic script and adds machining stock based on the type of substrate, based on the material. So here it's tool steel, so it just goes into like a lookup table and goes through tool steel, and then adds stock based on how much the machinist, the machining handbook tells you to add for that material. And finally, what it kicks out here is it kicks out what I need to buy, or what I need to order, or what I need to tell my purchasing guy. All right. I use Codex for the development process and to take this build from a very early prototype that was using a different LLM and brought into this, which has been much more reliable. So anyways, appreciate it. Thanks for checking in.